Hello there and welcome to a brand new lesson. This is How Beyond Numbers, where we learn maths the easy way. In this lesson, we are looking at linear inequalities, that is, in one variable. By the end of this lesson, you should be able to define a linear inequality and distinguish it from linear equation. You should be able to solve linear inequalities algebraically, including the rule for reversing the sign. You should be able to represent solutions on a number line using open and closed circles. To be able to write solution using inequality notations and interval notation. And finally, to be able to solve compound inequalities of the form a less than x less than b. We have some vocabularies here we'll be using as this lesson proceeds. I advise you pause and quickly take a glance before we begin this lesson. Without much ado, let's quickly look into it. Let's start by first of all looking at what linear inequality is. When we talk of linear inequality, it's simply a statement that compares the linear expression to a value using these symbols here. So we have the less than or equal to, the greater than, or the greater than or equal to. It does so instead of this we have here. This one is the equal to symbol. You see? So anytime you see any of these symbols, then it is an inequality. You see? So talking of these symbols, we have 4 of them, as you can see. So the first one, as I said, is what? The less than. Strictly less than. So that when you say x is less than 5, then we are talking of numbers that are strictly less than 5. So that is from 4, then come to 3, then come to 2, 1, 0, then the negative domain as well. All of those satisfy this inequality here. So that is what we mean by less than. So for less than, you don't include the endpoint. On the other hand, when you have less than or equal to, if I say x is less than or equal to 5, then listing out these elements here, you would start from 5. You see, so 5 and then all the numbers that are less than 5 because of the presence of this or equal to over here. So anytime you see or equal to, it adds the value itself. There is this other one we call the greater than. So if I have x is greater than 5, then the values that satisfy this inequality will be 6, 7, 8, and it goes on and on and on because it is strictly greater than. On the other hand, if I say x is greater than or equal to 5, then for that it is going to start from 5 and then it goes upwards. With this in mind, it is important we know how to solve linear inequalities. Now, when it comes to solving inequalities, the rules are just as applies to equations, except one rule. So that is to say, whenever there is multiplication, you multiply. Whenever there is division, you divide. When there are brackets, you know how to deal with them. When there are fractions as well, you know how to deal with them. But then the only critical difference is what we call the flip rule. The flip rule. The flip rule says that whenever you multiply or divide both sides by a negative number, then you must reverse the inequality sign. What does this actually mean? So let's say we have a negative 2x, which is less than 8. If we are solving for x, then using what we learned from equation, all we need to do is to divide both sides by 2, by negative 2. So you are going to divide by negative 2, then divide by negative 2. Now the rule is saying, since we are dividing, the flip rule is saying that this sign we have here is not going to remain as the less than. Because we are divided by a negative, then we have to flip it. See, so that it becomes what? A greater than. That is the only rule that changes when it comes to inequality. You see, so using the flip rule, If you have less than, it becomes a greater than. If you have greater than, it becomes a less than. If you have less than or equal to, it also becomes greater than or equal to. And if you have greater than or equal to, it also becomes what? A less than or equal to. That is all on the flip rule. So with all this, we can quickly solve some examples on the linear inequality. But then one last thing, you need to know how to represent your inequalities on a number line. So let's look at the number line representation. Representing inequalities on a number line is very, very simple, and you would see that very soon. We have what we call the closed circle and the open circle. So as you can see, this is a circle, and then we have this as well, also being a circle. Now this circle here is open, and this circle here is also closed. So we use the open circle for the greater than or the less than. So anytime you see greater than or less than, you use an open circle. But then if there is an element of or equal to, you see, so there's less, greater than or equal to, and this is less than or equal to. So if there's an element of an equal to, they would have to shade the circle so that it becomes a closed circle. You see, so for without the equal to, we use an open circle. With the equal to, we use what? A closed circle. And then we have the arrows. So the arrow points to where our inequalities are facing. So if you look at this arrow over here, you see it is pointing towards this direction. So this arrow is used to denote these, which is the greater than. Then for the one pointing towards the left, we use to denote the less than. You see, so that is to say, if you have greater than and you want to combine these two, then greater than is going to be your circle and then the arrow. So you have it this way. Very simple. So this is your greater than. Now for greater than or equal to, it is also going to be something similar, but with that, we need the closed circle. So this is how it's going to be. We would have to close it, you see, and that is going to be for greater than or equal to. And the same applies to the less than. It's just that the arrow points in the other direction. So that is it as you see over here. Now that we know how they look like, how do we actually do our representation on the number line? So let's take an example. So our first example here says you have to solve and represent on the number line 3x plus 5 greater than 14. 3x plus 5 greater than 14. So how do we go about it? We have 3x plus 5, which is greater than 14. And as I said, we solve it just as we do for equations. So we want to make x the subject. We would have to move 5 to the other side first. So that becomes a 3x greater than, we have our 14 written first. Then the 5, which is a positive 5, moves to the other side as negative 5. Evaluating further, we have our 3x greater than 14 minus 5, then gives us a 9. So solving for our x, we'll then have to divide both sides by 3. Why 3? Because 3 is what is multiplying the x over here. So this x, this 3 cancels out to this 3. Then we have our x, which is greater than what? 9 over 3, which is also a 3. Now we have solved it. We then have to represent on the number line. So let's draw our number line. So this is my number line over here, and it says greater than. You see, greater than, there is no or equal to. So with that, what we need is our open circle. Now with the open circle, we are going to put it on 3 because 3 is the number we have here. So we come all the way to 3, and I'm going to put my open circle over here. You see? And we also said for greater than, then it means the arrow is pointing towards the right hand side. So all these, you see, so this is going to be our representation on the number line. Very, very simple, isn't it? I told you. So this is the solution to our inequality. Now, there is something we call the interval notation. So even as we have solved, this is the solution. This is its representation on the number line. If you want to use the interval notation, we are going to say, therefore, our x is greater than 3, you see. Or, so using the interval notation, we'll say what? It is within the interval 3 and then infinity. Because as you can see there, if you want numbers that are greater than 3, it goes on and on and on. You see, so that is why we include this infinity over here. And take note of these brackets. They are not square brackets. You see, we use these brackets to indicate that the 3 is not part of the solution. Let's take some few more questions. So our second question says we have negative 4x plus 3 less than or equal to 15. So we have negative 4x plus 3 less than or equal to 15. So just as I said, we solve using the procedure of what? Equations. This is a positive 3. So we'd have to move it to the right hand side. So that it becomes a negative 4x less than or equal to, we have a 15, then minus 3. We have our negative 4x, which is less than or equal to 15 minus 3 gives us a 12. So this is what we have. And if you want our x, then we'll have to divide. Now, in dividing, you realize that it is a negative. You see, and I'll use this to illustrate to you why we end up flipping the signs. So we are going to solve it 2 ways. And after this, you would get to know why we flip the signs. The first one, using our flip rule, since we are going to divide, then we have negative 4x. And since I'm dividing by negative 4, I'll end up flipping. So that instead of less than or equal to, I'm going to write greater than or equal to. I have my 12, then divided by negative 4 as well. So with that, we have our negative 4 dividing our negative 4, and hence we have our x, which is greater than or equal to 12 divided by negative 4 gives us a negative 3. Now if we come to this, we have a negative 4x, which is less than or equal to 12. So what do we want to do? I don't want this to be negative. So let me rather take it to the right hand side and then bring the 12 to the left hand side. By so doing, my 12 comes to the left hand side, so that it becomes a negative 12 less than or equal to, then my 4x, which is negative, moves to the other side to become a 4x. And since it is x that we want and not 4x, what I'm going to do is I'm going to divide both sides by 4. You see, this time around I'm dividing by 4. So this side gives me a negative 3. Then we have less than or equal to x. So with this, if we are to read it from the left hand side, it is negative 3 less than or equal to x. But if you are reading it from the right hand side, then it is x greater than or equal to negative 3, which is the same as what we have over here. So we don't actually want you to be going through this flipping, or in other words, moving your variable to a favorable side to solve and then end up reading it from the left. So we are simply saying if there's a negative, divide all right, but then let this inequality symbol be flipped. You see, so therefore x is greater than or equal to what? Negative 3. The interval notation is written as, so use a square bracket You see, so -3 to indicate that the -3 is also part of the solution because we are saying or equal to. You see, so then comma infinity because it goes on and doesn't end. So this is what we put over there. Unlike the previous one, you see we use these brackets, two of them, indicating that 3 is not part. But for this particular one, the -3 forms part of the solution because it says or equal to. Now for this third question here, you realize that there are some cases where we don't have just one inequality symbol in the question. So just as what you see, there are two inequality symbols. It says you have to solve and represent 2 less than or equal to 3x minus 4 less than 14. That is what we have. So how do we solve this? We have our 2 less than or equal to 3x minus 4 less than 14. So if you want to solve this, let's take note of where we have the x. The first thing we'll need to take out of this is your -4. And how do we take out -4? By adding 4 to it. Now there are 3 different parts. So this first part, this second part, and then this third part. That is as you see in the boxes. So I'm going to add 4 to every side. So this first side becomes a 2 plus 4. Then for the second side, which is this, I have a 3x minus 4 plus 4. Then for the third side, I have my 14, then plus 4. 2 plus 4 gives us a 6, so we have 6 is less than or equal to 3x minus 4 plus 4 gives us a 3x. Then we have our less than 14 plus 4 gives us what? An 18. So this is what we have now. X is still not alone. So what we are going to do is we divide all the terms or all the 3 parts once again by 3. We are doing that so that we can eliminate the 3 that is on this x. You see. So with that, I'm going to divide by 3, divide by 3, and also divide this side by 3. So I have 6 over 3 giving us a 2. So we have 2 is less than or equal to 3x over 3 gives us an x. Then less than 18 over 3, which also gives us a 6. This is our solution. Now, if you want the interval notation of this, then you realize that for the x, it is or equal to 2. So we use our square bracket and then put our 2 there. But then it is less than 6. So you put our 6 and then use this bracket. You see, that is the interval notation. What of on the number line? To represent this on the number line, you realize that there's both the or equal to and then the less than. So we are going to use all the 2 circles. The or equal to is going to be on 2. That is, the closed circle is going to be on 2. And then the open circle is going to be on 6. This is what I have here. You see. And this time around, you just join them with a straight line. So I'm just going to join it this way. And that is all. This is how you represent this on your number line. This one, you are not going to use the arrowheads because there are 2 circles where you have your solution set within these 2. So it becomes this way as you see it. We have 2 more questions. And our last one is actually going to be a word problem. So I advise you stay tuned. And for this 4th question, I would also advise you pause and then try it on your own. Our 4th question here says you have to find the integer values of x that satisfies -3 less than 2x plus 1 less than or equal to 9. So we'll solve it just as we did for the previous one. And as I said, you pause and then try it on your own. If you're able to do it on your own, well done. Now let's do it together. We have a negative 3, which is less than 2x plus 1 less than or equal to 9. So how do we solve it? We would have to subtract 1 from all the 3 parts. So that for the first part, we have negative 3 minus 1. You see? Then less than 2x plus 1, then minus 1, then less than or equal to 9 minus 1. With that, we have a negative 3 minus 1 giving us a negative 4. Then it's less than, we have a 2x. Then positive 1 minus 1 goes off. Then we have a less than or equal to 9 minus 1 gives us an 8. With this, we would have to make the x the subject. And how do we do that? We would have to divide each and every term by 2. 2 because we have the 2 multiplying the x. You see? So negative 4 divided by 2 less than 2x divided by 2, then less than or equal to our 8 divided by 2. Negative 4 divided by 2 gives us a negative 2. So negative 2 is less than 2x divided by 2 gives us an x. Then less than or equal to x over 2 also gives us a 4. Now this is what we have. It says we are to find the integer values that satisfy. So we then have to list out the integer values within the set. Now take note, it says x is greater than negative 2. So if you want integer solutions of x, we can say x is an element of. Then we list out the element in this set. Negative 2 is not going to be part because x is greater than negative 2. So we rather start from negative 1, 0, 1, 2, 3, and then we end at 4 because it says or equal to 4. So we include our 4. And this here is going to be our integer or values of x that satisfy this inequality. Now, the interesting thing is you can always confirm your answer by substituting these values, any of them, into what you have here, and you'd realize that it will be true. If not, then it could mean that you didn't actually solve it well and you have to take your time and do it again. If you paused and solved and you had this solution, then I can confirm you have really understood this topic. Let's now look at one word problem, then we can call it off. So looking at our last question, it is a word problem. It says, Abna is taking a course with a total of 5 exams. To get an A, the average of all 5 exams must be at least 85. She has already finished 4 exams and her average score so far is 78. How many marks must she get on her last exam, that is the 5th one, to bring her overall average up to an 85? How do we go about it? First of all, is it even a problem involving inequality? You can let me know at the comment section. Now we know an average. The average is simply the sum over the number of entities. So looking at what we have here, it says the average so far is what? 78. So that is to say that we have 78 being equal to the sum all over n. How many exams give us the average of 78? 4. So all over 4. Then the sum of these would then be 4 times 78. So the sum of the 4 subjects is now what? 312. Now we need the average to be greater than or equal to 85. That is the statement over here. So the average of all 5 must be at least, you see. So that is to say that we need the average to be what? It should be greater than or equal to 85. That is the average of the 5. Looking at it then it means if we are to write the 5th exam and add to it, the new sum of the 5 subjects is then going to be what we have of the 4 subjects, which is 312 plus, let's let the new one Abna is going to write be x. You see, now using our average formula now, which we are saying it should be greater than or equal to 85, then finding the average of this, it becomes 312 plus x all over 5 should be what? Greater than or equal to 85. You see, so with this, we now make x the subject. We can choose to what? Cross multiply, because we have only one term and then only one here. So cross multiplying, we have 312 plus x times 1, which gives us a 312 plus x is greater than or equal to, we have 85 times 5. Making our x the subject, we say x is greater than or equal to 85 times 5 gives us a 425, then minus what we have here, which is 312. So you see our x is greater than or equal to what? 113. Now looking at the answer we are getting here, you know, for an exam, for a standard exam, it is over 100. That is the percent. It is over 100. So if our calculation here is telling us that Abna needs to get 113 before her average comes up to about 85, then it simply means Ajwa is actually not going to get to the 85, because even if she gets 100, it is still not going to give her that average mark. So our conclusion is that it is impossible for Ajwa to actually get that average, irrespective of the last score she gets in her final exams. So we'll conclude by saying, therefore, Abna cannot achieve an A average. She would need 113 over 100 on her final exam, which is impossible, right? That is unless the grading system is not over 100. So that ends our lesson on linear inequalities. As usual, I'll leave you with an exercise so you try on your own. So here you are with the 5 questions. I would advise you pause and then attempt them before you move on, just to test your understanding. Let's have Beyond Numbers, where we learn maths the easy way. If this lesson was useful to you and this is your first time, you can choose to subscribe if you so do wish, so that anytime I release a video, you'll be notified as well to learn along. If there's any issue of concern, you can always let me know at the comment section, and when notified, I'll address that for you. See you in our next lesson, and bye for now. Do stay safe.